All right, welcome to today's webinar. This is the third in a series of 6 webinars we're doing here this fall and winter. Today we're going to focus on mainframe to cloud data integration. I am Dustin Froyam. I am one of the co-founders of VirtualZ Computing, and today I have our CTO and co-founder Vince Ray with me as well. So thanks, Vince, for joining us.
Oh, happy to be here.
So we're going to focus a little bit on the challenges of legacy data integration. How our solutions work, and then review benefits of our integration mainframe in the cloud with VirtualZ. And then we'll do some Q&A. Today, we're going to focus on a couple of our solutions that focus on this. We do have 3 solutions in all, but this will focus on a couple different patterns with those 2 solutions. So let's talk a little bit about kind of where things have been historically. So if you're looking to integrate mainframe data to cloud or even distributed platforms, this is not exclusive to the cloud. A lot of that can be very resource intensive, including using your general processing capacity to, extract and transform the data, as well as get it loaded into an alternative platform, or in some cases, the ELT or ETL, both of those patterns. We have customers that tell us up to 40%. We've heard that a few different times. I don't know what's magic about the 40, but we've heard that a few different times. Typical is usually in the 15 to 30% range, though, but that's still an enormous amount of resources being used just to share data from your mainframe. And then, as we all know, there's pressure on the scarce labor resources, especially your mainframe talent, and having to maintain these legacy ETL and change data capture routines to share the data. Lack of agility is an issue. So not only just the resource issues, but the long time to value that traditional tools take. We were just having a conversation with a customer the other day, and every time they get a new source file that they need to integrate, it can take weeks to get that set up, mapped, etc. And we'll talk a little bit about how we solve that problem as well. Can be very fragile, these systems, especially when you start incorporating change data capture, and require a lot of ongoing maintenance. So even that customer that was describing that pattern had a lot of maintenance to do, even when there were small changes in their environment. So if you just think about what it takes, if you have a new data source and a new data target, how long does it take your enterprise to, integrate those two and get up and running? And again, what we'll talk about today is how you can bring that from weeks down to hours and even minutes in some cases. And then the disaggregation, right? So if you don't do the integration, then you have to deal with reporting, and especially in this time of AI, you have disparate data sources, or you're having to implement different AI or BI platforms specific to the system you're using, right? If you think about mainframe reporting or mainframe BI compared to some of your distributed and cloud BI and AI, why would you not want to bring that together? And then, security can be an issue too, right? If traditional ETL, you have multiple copies of your data floating out there. You may not be able to control that like you would want to with mainframe security for your most sensitive data. Certainly we support a pattern for more efficient ETL, but we also have a solution where it gives you full single system of record and that security, and we'll talk about that. Yeah, I'm going to talk a little bit about our first solution that we're going to go through, and this is a data it's a data sharing platform where it really does traditional ETL or ELT in a more efficient, cost-effective Very, very fast, rapid solution. And I'll play just a little graphic to show you what this looks like. So our solutions are mainframe solutions, and so it sits exclusively on the mainframe. This has some benefits to it, though, is that we can multiplex to multiple targets, either simultaneously or in sequence as well. And so you really don't have a lot of restrictions. And this animation just shows a few of the out of the box platforms that we support, and really the possibilities are endless, whatever your source and target platform is. So Vince, maybe I can just get you to dive in a little bit more on the architecture and the features of Propels and how that supports some of these data integration challenges for the customer.
Yeah, no, that's happy to do that. So, a common thing we hear from customers all the time is they have huge amounts of valuable data locked away on the mainframe in file formats that just aren't easily processed on other platforms. You might have a mainframe, I don't know, a vsam file, sequential files, legacy kinds of data like that has really mission critical data in it, but getting that into a form where you can use modern tools against it is not the easiest thing in the world. That's what Propels deals with. We take that data from all of these complicated structures and we put it really wherever you need it. Now, the first point I want to make is that it is very open that way. The list of targets we can support, probably about 100 different database types. We use industry standard JDBC technology, so any database with a JDBC driver can be made to work with Propels. That includes, certainly all the traditional, Oracle and Microsoft SQL Server and those types of databases. But it also includes things like Snowflake or MongoDB or some of the more modern NoSQL databases. Uh, the way we package it, we deliver, I'm going to call it 5 certified databases right in the box. That's MySQL, that's Postgres, that's Oracle database, that's Microsoft SQL Server, and Snowflake is the 5th. But as I said, the sky's the limit. If you have a need for some unusual database, you want to go to, I don't know, Ingress or Teradata or whatever it is, that's something that we can deliver for you. We're happy to do that, but really you don't even need to rely on us. It's really just a matter of configuring Propels to generate the SQL queries that your target database expects, and then you supply a JDBC driver. That's really all it takes. You can get that from us. You can develop that yourself, depending how comfortable you are with that. No code required. I mean, that's the key point here. Now, an important part of what we do in this process is that we understand those mainframe files at a very deep level. So just as an example, you might have a mainframe vsam file, and within the records of that file are lots of different data types. Some of the fields might be text fields. And of course, if it's on the mainframe, those are probably encoded in EBCDIC. They obviously need to be translated to, ASCII or UTF-8 or whatever your application expects. That's certainly one part. But you might have other fields in those vsam file records that are, maybe they're binary data, maybe they're packed decimal, maybe they're mainframe style floating point or mainframe style timestamps. Propels has the ability to look at that file field by field using a little bit of metadata that you provide to tell us what those fields are. And then we'll transform those records into columns in the target database. So, if you run Propels the way I'm describing, and you go look at the resulting database, it's not just a blob with, one row per record in the vsam file. It's that vsam file broken out into, name and address and, all the other discrete fields that are found there. Now, the way that works, I mentioned metadata. The metadata we use generally is nothing more than a COBOL copybook that describes the vsam record. You point to the copybook, we understand the fields, the different types, their lengths, all of the attributes of the records in the file based on that, and that's what we use to do the transformation. So that gives you the ability to go to not just take that raw data. Now you still have this hard problem of how do I process it, but take that data, break it down into its individual columns based on the data types, and then you're free to use really anything that the database supports, whatever SQL queries you want against that data. You get to control a lot of that through the configuration, by the way. If you decide that, I don't know, maybe you want fixed length character fields, you're able to tell Propels to oh, and Dusty, your screen just stopped. But
Yeah, I'm sorry about that.
oh, that's okay. But so you get to define, if it looks like this in the vsam file, here's the database data type I want you to use. So you have a lot of control over that. You have a lot of control over things like the indexing that'll ultimately end up on the database. Whatever that that vsam file may have had keys, may have had record keys. We propagate those to the target, but really any field in the record can also be used for a database index, and we can create all of that automatically as we populate data. The other thing that's important here is that with Propels, it's not a all or nothing kind of an operation. Sometimes the data you're dealing with is enormous. And so there might be, I don't know, billions of records, and if you had to process that file, let's say once a day, it would take a long time. It would take a lot of network capacity, a lot of resources, and certainly that's not what we're after. So we also have the ability to do incremental processing. So just as an example, I could take let's say a vsam file that has a transaction log of something going on in some mainframe application. You can keep track of the last thing that you saw when you were Propels, and let's say an hour later or the next day, or whenever you run it again, you can tell Propels, don't start at the beginning of that data, start with the last key that I saw and just get me everything since then. And then that keeps your data up to date without necessarily having to transfer what could potentially be terabytes of information per operation. So you also can, I mean, there are a variety of different ways you can run Propels. Commonly what we see people doing is they have let's say production batch work that creates the mainframe files that they want to replicate to the cloud somewhere. It's a really simple matter to add an extra step to that process. It's okay, after my file is created, I'm going to run Propels, and it's going to put a copy of that data in Microsoft SQL Server database, or wherever you happen to want it, or maybe even many places if you wanted to go many places. So that's one model, and that's great for kind of recurring use. It can also be done totally ad hoc, command line. Just type in the Propels command, specify here's my data, here's the metadata that describes it, and here's the target I want to use, and we'll handle the rest. So yeah, a lot of flexibility in the way that it's run, and because of the way that we're doing this, I mentioned before that the protocol that we use is industry standard JDBC. Well, JDBC is optimized for database traffic. It's it certainly varies depending on what database you're talking to, but it's generally about as good as it gets from a performance point of view. And just to put some expectation there, we we'll take the, in our test environment, and mind you, our mainframe is the smallest possible mainframe, and it's not even a real mainframe. It's an emulated mainframe that runs on, basically a PC. It literally sits next to my desk here as I'm speaking to all of you. It works out to be about less than 100 MIPS or so in mainframe terms. We run Propels there. We use nothing but consumer grade, internet connection, so a gigabit connection to the cloud. And on the cloud, we're running a free tier database in the Amazon cloud. And in that configuration, and like I said, it's hard to think of a smaller configuration than that, we're able to get somewhere in the vicinity of about 6,000 rows per second using our technology. We believe on a big heavy duty mainframe with serious bandwidth and either an on-prem database or something where you have a lot of connectivity to the cloud, it should be no trouble at all to do 10 times that kind of volume. So throughput, we feel really good about. And then the last thing I wanted to mention is that we've also been careful that 100% of Propels is designed to be zip eligible. So, a lot of customers are concerned. I put new work on my mainframe. It's going to drive my mainframe software bills higher. But the way that Propels is architected, we run on one of those IBM specialty processors inside your mainframe, and that doesn't spin the software meter. So, you can run as much Propels as you want, and ZOS and DB2 and all the other IBM software running on that ZOS system are not going to go up in cost because of the Propels workload. So that helps to keep it, very, very affordable from a resource consumption point of view. So, end to end, Propels lets us solve these problems where the goal is to kind of unlock something that's on the mainframe. I mean, Dusty and I were on a call recently where I felt so bad for the poor customer. They have dozens and dozens of files that they're trying to process in the cloud, and the way they described it was that it literally would take them weeks of manual work to understand the structure of the file, to create custom software to move those records to the cloud. I mean, and it was so brittle. If God forbid there was a change to one of those record layouts, they had to go back and do all this again. With Propels, if there's a change to your data, you update the copybook that supplies metadata to us and run it again, and that's it. You'll see a new column in the database with whatever that new field. So a very different mindset. If what you're accustomed to is the pain of trying to do this manually, this can free you from that. And in one of the examples, and I would invite all of you to see our examples. I'm sure Dusty will have a link later on. But in the demo, we talk about, we started with a vSAM file that, it's open source, public domain information that has one record for every airport in the entire world. And we chose that data because it has a lot of different data types. There's character data, like the name, the airport, and the descriptions. There's floating point, like latitudes and longitudes. There's binary numbers, like the elevation, feet above sea level of the airport. There's a little bit of everything there. We had the COBOL copybook that described it, and you'll see in the demo we recorded, it's literally 5 minutes. We go from that file on the mainframe to generating Tableau, geo-referenced maps showing all the airports in the U.S. is what you'll see in the demo. So nothing manual, not one line of code written. fast. In that case, we're using the MySQL database, but honestly, that's irrelevant. It works the same way no matter what database target you're going to. So, if you've got that problem of trying to get kind of legacy data out of your mainframe into some more accessible place, then Propels is a great solution for that.
Yeah, Vince, I just remember that customer who's pretty excited about how we can help them. I think they asked 3 or 4 times. So how long does it take to get get the data transformation mapped out? And, we had to keep explaining that, well, it's basically automated and it's instantaneous, right? It's just part of the overall process. And, um, so that's just a great story for that customer, and they have a huge opportunity to save some time. There's a question in the chat, and it's a great segue because we're going to talk a little bit about higher order real-time read-write access that actually completely eliminates change data capture. I'll just mention Propels generally is a one direction, right? So we're pushing that data out. Now, it doesn't have to be, like Vince said, in the batch window, it can be incremental and it can be online. So that creates a lot of efficiency for that. I would invite you to join us for a couple of our future webinars, and I'll highlight those at the end, where there's actually a restore function because Propels has a kind of a storage or backup role as well, or use case. But today, generally, when you're doing data integration, this is a one-way push out to your target data lake, database, etc. I'm going to just quickly mention pricing. And this is one of the reasons why that other customer's very excited, is because they're just spending a lot of resources on just traditional ETL, where we can no code automate that for them. We're a little different than other mainframe companies. We publish our prices, and so they're available right on our webpage. Propels is $50,000 per year, unlimited amounts of data, no MIPS restrictions, no CPUs, no LPARs, no data centers. It's $50,000 per year for your enterprise. If you do have a custom driver that you would like us to work on, very nominal upcharge. I mean, we're talking about a few $1,000s, nothing major, on top of the ones that we ship out of the box. So that's, we'll be glad to support those, but let's have a discussion about that if you need it. And again, it's very cost effective. Okay, Vince, I'm gonna so since that question was kind of a really great segue into this, why don't we talk a little bit about the patterns and the features of Lozen, which is, let's just call it a higher order product, which is actually maintaining a single system of record, if that's what you want to do, as well as, kind of full mainframe security, and eliminating that change data capture because of the real-time read-write function.
Yeah, no, and let me just reiterate what you said, that Propels is essentially a one-time transfer from mainframe data to wherever you want it to go in the cloud. If you've got the kind of application that's analytics or reporting or whatever it is, that's probably what you need. On the other hand, if you've got maybe a more transactional application, in other words, what you want to do is read that mainframe data, update it, and store that changed data on the mainframe. This is a whole different kind of a use case, and it's one that customers also tend to spend a huge amount of time and energy on, because it's a difficult one. If I'm moving a record to another platform, updating it, and trying to get that updated record back to the mainframe, I have a whole host of problems. I mean, one of them is, how do I know that that record hasn't been changed by some other mainframe application while I changed it on the distributed side? There's a whole lot of coordination that needs to go on there. And a lot of the attempts we've seen at solving those problems are just incredibly complicated, fault prone, slow, on and on and on that way. So, we took a look at this, and this actually, Lozen was our first product in this space. Lozen was kind of a different answer to that problem. What we did was we said, well, what if instead of this paradigm of replicate the data, update it somewhere else, and then try and replicate it back to the mainframe? What if instead of that, we allowed you just to have complete read and write access to your mainframe data in any way you want, anywhere you want? It could be anywhere in the network, could be by any type of application. And that's what Lozen provides. So in Lozen, instead of taking that legacy mainframe data and moving it somewhere, you leave it right where it is. It stays in vSAM or whatever other format it's in. It stays on the mainframe. Lozen provides a high performance read access to it, so you're able to read in real time. Even if that data is constantly changing, you're able to read the current copy of that data. And if you want to, you can update it from, again, from anywhere you need to. From, a Java transaction running in the cloud someplace can update that data. And because you didn't update a copy of the data, you updated the real data, all of those issues of how do I integrate my changes back into the main, that all just goes away. You don't have any of those problems. You have the same environment you would have if that application doing the update were running right on the mainframe. It has access to the file, it reads what it wants, it updates what it wants. More than that is, in the example we talked through with Propels, the idea is one way or another, you're working with a lot of data, because you don't know what the application needs. The application might only, that thing that maybe is running out in the cloud might only want to process a handful of records, but you don't know that. You don't know which handful of records. So you tend to synchronize the whole file. You replicate the whole file one way or another. And, you might do that incrementally as I described, but it's still a lot of data that ends up in the cloud. With Lozen, we don't just give you access to the records in a simple way. We give you all of the capabilities of things like vSAM. So if I want to read one record by its key, I can do that. I don't have to transfer that entire file to get that one record. I just read the records I need in my application. And same thing for update. If I just want to read that record, change something in it, and write it back to the mainframe, there's only one record moving back and forth across the network in that case. I don't have this issue where we've got to move, maybe a terabyte of data so that the application has whatever it needs to have. You only move the set of records that you need. And on top of that, you have access to all of the sophisticated things that mainframe access methods could do. You want to do, I mentioned one of them. You want to do vSAM style read a record by its key. Absolutely, you could do that. You want to read by record number. Absolutely, you can do that too. You want to read by um, backwards, point to a particular record and then read backward from there. You can do that. You want to delete a record in the middle of the file, you can do that. You want to insert a record in the middle of, anything that's possible to do with mainframe files is possible to do through Lozen. And, like Propels, it's very high performance. We use protocols. In this case, they're based on industry standard NFS protocols. And the idea is that, unlike some of our competitors that use things like HTTP, which is a text-based protocol designed for web transactions, what we do is use a protocol that's based for file transfers, that's based for binary file system data, that does sophisticated things like caching on the client side, so that if I'm going to read the same record 1,000 times, I don't have to physically read that record 1,000 times. I read it once. It goes into the cache on the client, and it's there until either it's changed or until something more important comes along. So a lot of capabilities are unlocked by Lozen to allow applications to really just act as though they were on the mainframe and have all of those same capabilities, no matter where they are. And because it's, I mentioned it's based on industry standard NFS, you need very little proprietary software from us to access that file. In fact, some of our demos, we assume there's none of our software on the client side. It just does normal kinds of file system operations against against Lozen, and it's able to do all the sophisticated things I talked about with whether it's VSAM or sequential files or other types of mainframe data. Now, in some cases, maybe you're writing a new application from scratch and it's easier to use a proprietary API. We can give you that too. There's one in Java, there's one for, C++ environments. And, so if you want a simple method to call that, go fetch me a record by its key, that might be easier for you to do. But there's no hard requirement for that. We also,
Oh,
go
see.
ahead, Des.
Vince, we got a question. So this goes to data integrity around locking. How the file's defined, RLS, transactional VSAM, potentially. Could you speak to that just briefly?
Yeah, so the short answer is the integrity you get is exactly the same as if you ran your application on the mainframe. So it depends on the type of VSAM you're using. I'll call it legacy VSAM is a little bit different than RLS, and that's a little bit different than transactional VSAM. But whatever is there, those are the capabilities you get. So if you have transactional VSAM, you get full read write, two-phase commit, record level locking, all the things that you would expect in that environment. If you have old style legacy VSAM, well, then that's what you're going to get. Share options and all of that. We don't require any change to your VSAM environment. In other words, we work with whatever we find. There's no requirement to upgrade or change any of that or really do anything different. Even things like security policy. Lozen just honors your existing security policy. If the user involved had access to the data when he was logged in and running on the mainframe, he'll have access through Lozen. And if he didn't have access, Lozen's not going to give him access. So, it's really, that's the way to think of it. If you took that application and you could run it natively on your mainframe, how would it behave? Well, it'll behave the same way with Lozen, even though now it might be running in, let's say the Amazon cloud or wherever you need it to run.
Thanks, Vince. Hopefully that answered the question. Just type in the chat if it didn't, and we'll be sure to address it still as a follow-up. Vince, you were kind of getting into kind of the connector environment. Well, either the lack of needing to have a connector, but also what we do package, and maybe just highlight, since this is really about data integration, how some of these other data integration platforms, how we integrate with them as well.
Yeah, well, and I think, just one overarching point, I think you'll find that this is a big difference between us and some of our competitors. We don't want to go to customers and say, look, here's our proprietary way of getting to your data. It's either that way or the highway. It's, do it our way. What we believe is that you should be able to get to your data in the easiest way possible, depending on the application that you've got. As I described, sometimes that means nothing of ours. Maybe you're running, I don't know, an Android application, and it's sitting there on somebody's phone, and it needs to make a connection to a mainframe to read a record or two. You're welcome to do that without any of our proprietary code at all in that environment. As I described, that's just native NFS transactions, and almost every platform on the planet includes an NFS driver built in at the operating system level. So, that's one extreme. The other things are, things like our Micro Focus. I guess now Rocket owns Micro Focus. But the idea is that I might have a COBOL program that I run on my mainframe, and what I'm looking to do is migrate that COBOL program to some other platform to save some money. Well, that COBOL program probably has a lot of really complicated, let's say VSAM IO functions in it. It's opening files, it's reading them certain ways, doing all sorts of things with VSAM. We developed a connector for the Micro Focus environment so that you can plug in our connector and run that COBOL program completely unchanged, no source code changes whatsoever, and it operates against the same exact VSAM files it always operated against. So, in that case, you don't really even need to know Lozen is in the picture. It just behaves exactly like that application were on the mainframe. So, those are kind of a couple of examples. I mentioned we do have our own proprietary API. If you tell us you're writing, I don't know, maybe a brand new Java application from scratch, we can, certainly give you something like that that makes it, much simpler to access the data. It's kind of streamlined for things like VSAM operations. But to Dusty's point, sometimes your idea of data integration is more than what we've been talking about so far. What you want to do is maybe take a couple of records from a mainframe file, maybe you want to change them somehow, maybe you want to combine them with data from, I don't know, a database or some other location. Often people use, the ESB products, Enterprise Service Bus products, MuleSoft or Boomi or Tibco or Microsoft Azure Logic apps. I mean, there are many products in this space that can do what I described. It's usually kind of a workflow approach. You'll go do this, then join it with this, then join it with this, then publish the result. We also built, really, it's two different connectors there for MuleSoft. Uh, and MuleSoft is part of Salesforce.com these days, but they are one of the leaders. So we built an integrated solution for them. And the way this works is it's purely declarative. In the development environment, you'll see a Lozen tool. You drag that into your workflow, configure a couple of things like here's the name of the data set I want to read, and what do I want to do? I want to do search by key and read 3 records, and you're done at that point. That's all you have to do there. It fits right in their development environment that way, very smooth and easy to use. For some of the other products, the standard there is Open API. It's really that same exact idea, just a different standard. So any Open API consuming application, which is beyond the things we're talking about here. There are probably close to 100 different vendor products that know how to work with Open API. They can consume mainframe data the same way. Here's a declarative way to expose access to mainframe data, and you can do whatever you want with it. By the way, both of those last two that I talked about, actually all of these, it's not just for read-only access. You also get update access there. So again, if I wanted to write a MuleSoft flow that, I don't know, maybe it took an email in, did some analysis of it, and one of the things that could come out of that is a mainframe file gets updated. That's totally possible without really writing a line of code, just by configuring the connector that we supply. And by all means, I wouldn't think of this as the finite list. We're not looking at this saying, okay, we're done. If customers give us a great reason to do something else, that's not on this list, we're eager to hear that. I mean, like I said, our approach isn't to put stuff out and say, here it is, do it this way. Our approach is to make it as easy as possible to get that mainframe data wherever you need it in the way that's most natural to do that sort of thing. So Dusty, what did I miss? Anything
No,
I should
I think
cover?
that's a good overview. It's a good primer for actually some of the application modernization we're going to talk about in a future webinar as well. Um, I'm just going to quickly touch on the Lozen pricing. Again, it's published, it's out there. We charge by the volume of data. Again, think of this as discrete access to the data. So, the data limits are lower, but if you needed additional data, this is something we can certainly talk about. We're meant to be very, very cost conscious and cost competitive in the market. It and Lozen does ship with obviously the NFS function, that protocol right out of the box, as well as the Java and our C++ APIs as well, as part of that. And then you can, if you needed those additional connectors, we basically charge a maintenance fee for that, just to keep those up to date. Um, I think we've touched on a lot of these benefits along the way. So I'm not going to review these one by one, but they're here in the summary. If you're watching the playback, you can pause here and just take a look at those things. But those are all things we've covered throughout the agenda here. And then I'll just pause here. I know we got a couple questions along the way, and this is a good time to chat. Type in the chat if there's additional questions. But I had one, Vince. So recently we had someone ask us and this was a Propels question, could we do mainframe DB2 to Snowflake? Is that something we can support as well?
Yeah, and I should have probably mentioned this while we were talking about Propels. So the default, and the way I described it is read legacy mainframe files, VSAM and others, and write to JDBC connections that are various types of databases. In actuality, it's more open than that. It turns out that it's possible to pipe just about any type of data you want into Propels. So if you wanted to, maybe you have a application or transaction or whatever it is that generates some interesting data that you want to process through Propels, you can absolutely run that and then send the output directly into Propels, and it'll do its normal thing. It'll go to whatever destination you want with that. And because in your example, Dusty, DB2 supports JDBC, so certainly DB2 could be one of the destinations there. But even if that wasn't the case, it turns out you can do that as well on the output side. The target doesn't have to be JDBC. The target can be virtually anything. So, some customers talk to us about, I don't really want to process the data once it's in a database table. What I'd like to do is every row of that input, I'd like to generate a transaction of some sort. So what I'm thinking is more like a publish subscribe model or a Kafka model, where Propels runs, it does its thing, and then it sends the record instead of directly to a database to a transaction of some sort. Well, it turns out we can do that too. And in that case, the thing that output program sees is, if it wants the raw binary data from the VSAM file, it can have that. But more commonly, what it's going to do is accept that record as, that's been transformed into either, something like JSON or XML or a CSV format. So, the way that would work is Propels takes its input, whether that's from a file or from some other program, applies the data transformation I talked about, and instead of transforming to a format that can go to a database, it can transform to, really, it's the format of your choice, typically, like I said, JSON or XML. And then that each row is passed to some target program who can do whatever he wants, send a Kafka transaction, send an MQ series transaction, drive a CICS transaction, drive whatever you need to do can be accommodated there. So we have examples of this working with system data. Like one of the use cases for Propels is to do things like archive your mainframe SMF records to the cloud somewhere. Well, in that case, the input isn't go read my SMF data set. The input is a program that we developed that captures SMF data in real time. So we see an SMF record being created by the system, goes into Propels, ends up in say an Oracle database sitting either on-prem or in the cloud. So plenty of those things are possible. It's the only limits your imagination that way.
All right, thanks, Vince. That's another great segue into some of our future webinars here. So um, next week, we're going to talk about application modernization and how we can de-risk that, make it go faster. And then part of what you were just referencing, we have quite a few customer engagements going with mainframe tape to cloud migration. So some of that is just pure backup, and some of that is transforming it to be accessible in the future by cloud and distributed applications. And then kind of a similar pattern, the unified access to mainframe management data, SMF, console, alerts, mainframe logs, etc. And then there's two other webinars from this series that are available on demand right now at our website or on our YouTube channel. So a product we haven't talked a lot about today, ZAC, which enables instant mainframe storage both as virtual disk or virtual tape. No code, no code on the cloud or the SAN storage side. So that's a really cool topic, and we're super excited about the capabilities there. And then mainframe report migration, which is the one we did last week. And so a little bit different pattern, again, really focused around Propels. There is some lows in use case in that as well. So check those out if interested. And then we've got a ton of resources, not just on these products, but different use cases, solutions, demos of all three products. So go check that out. There's the Propels demo that Vince referenced throughout this webinar. That's really cool. And like Vince said, in a elapsed real time, it's a very short amount of time. I think the demo is about 8 minutes, and the total real elapsed time isn't much more than that. So check that out. But there's demos on Lozen and Zach, including the MuleSoft integration for Lozen that we referenced as well. So, all right, thank you so much for joining us today and hanging on as we went a little over time, but some great questions and um, a lot of ground to cover. So, thanks again. Take care.